Okay, we're going to go into the second part of functions today. In the second part, we're going to talk about how to tell when a function is even or odd, increasing or decreasing, or constant. We're going to piecewise functions. We're going to do some transformation, inverses, and a one-to-one. And we're going to get back over variations. Even and odd functions. Even functions are symmetric to the y-axis, which means that if you fold it in half over the y-axis, they would match the left and the right side. To tell, you take the x out and replace it with a negative x. If you get the same answer again, it's even. And what it means is an even number will start at the top and end at the top, or start at the bottom and end at the bottom. Odd functions are symmetric to origin. So if you replace the x with a negative x and you get negative what you started with, that means that it starts at the top and ends at the bottom, or starts at the bottom and ends at the top. In other words, an even function will be both up or both down, and an odd function will be one's up and one's down. Okay, so we're going to take out the x and put negative x in squared minus 3. So we get negative x squared is x squared minus 3. We ended up with the same that we started with, so it's going to be even. So we put in negative x to the fifth plus negative x to the third, which gives me negative x to the fifth minus x to the third, which is everything's opposite, so it's odd. If I put in negative x, absolute value minus 4 is x minus 4. It's back to the original again, so it's even. If it doesn't come out even or odd, then it's neither. And that's possible too, so you want to look for that. But all we're doing is plugging in the negative x and seeing what happens. If it changes the signs, like here, it's odd. If it ends up exactly the same, it's even. Increasing and decreasing functions. Classifying according to the x coordinates, you read left to right. For example, x cubed minus 4x for x in the interval of negative 1 to 2. So from here to here, what's happening? Well, if we plot it from negative 1 to 2, you see what's happening. We have it starting at the top and decreasing down to here, and then increasing up to here. So without exact analysis, we cannot pinpoint where the curve turns from the decreasing, so let's just say that within this, the curve decreases over negative 1 to approximately 1.2, and then the curve starts increasing from approximately 1.2 to 2. And notice we have the brackets meaning inclusively. Okay. So a constant function is a horizontal line, and for what values of x is the function 4x squared plus 4x minus 3 increasing by the average change or rate of slope of the secant line. So f equals x to the 4. That's where we're going to start at. So if we graph that, and we do have a graphing calculator, we'll graph it for us. Find some points here. 0, 0, 1, 1, 2, 16. So we're way up here. Way, way, way up here. Let's go to the negatives. Negative 1, 1. Way up here. And let's take a look by changing the window, starting at 0 and going by 0.5, so if there's any change in that. And as you can see, there really isn't. So from -1 to 0, we have a decrease. And from 0 to 1, we have an increase. And from 1 to 2, we have an increase. Okay, graphing piecewise. In piecewise graphing, it tells you which part of the graph you're going to use for what part of the interval. So I'm going to use the x squared part up to -1. I'm going to use a constant of 1 from -1 to a. And I'm going to use x from x to 1. And this should be a 1, not an a. So, this portion. If I want to start at -1, because it's less than -1, the -1 and -1 squared is 1. Put in -2. -2 squared is 4. I put in -3. -3 squared is 9. So let's start with those points. So at -1, I go to +1. That's an open dot because it's not equal to. And then at -2, I go to 4. And at -3, I go to 9, 6, 7, 8, 9. So this is the part of the graph for that. Then I stay at 1 from -1 to +1, inclusive. So this is now going to become a solid at that spot. And then this is y equals x. So the formula is 1, 1, 2, 2, 3, 3. So 1, 1, 2, 2, 3, 3. It would have been an open dot too, but it's solid. And there's my piecewise graph. It just tells me how far I'm supposed to do each graph. So the next one, 1 minus x is below 0. So I'm going to start at 0. 1 minus 0 is 1. 1 minus 1, I mean -1, because I need it below 0. -1. 1 minus -1 is 2. 1 minus -2 is 3. So I start at 0, 1, open dot. You can see it's not, doesn't have the underline. Then -1, 2, and -2, 3. Then I go to the next portion, I have x, so y equals x. So, and it's going to be between 0 and 2, so I'll start with 0, 0, 1, 1, 2, 2. So 0, 0 is solid. 1, 1, 2, 2. And there's that portion. Then here, x is greater than 2 is -1. So -1, y equals -1. And put my x's in. Starting at 2, open dot, going across the whole way. There's my piecewise graph for that one. So you're just taking each of the graphs and graphing them only for the portion or the interval that they've given you to do. This is a continuous piecewise, and this is a discontinuous piecewise. But you're just graphing the portion they're telling you through the interval that they're telling you. Okay, this is a step function. A step function is the greatest interval less than or equal to x, and on the graphing calculator you can do it under int. Okay, so I put the graphing calculator up. So that y equals, clear that out. I'm going to hit, not that, hit math, num, and go down to int. And I'm going to put x in, close my parentheses, and graph it. And it looks like a stairs. Now yours might, depending on which graphing calculator you have, it might open and close where you want it to, but in a TI-83 or a TI-83 Plus it looks like stairs. Okay, with one end open and one end closed. If we go back and we put in the x minus 2, and remember from our transformation unit, all that's going to do is move it to the right 2. They moved it right, down 2. We moved it down 2. Okay, so that's a step graph. So you're familiar with that. Now a circle graph. A circle graph, and this is on your formula sheet, x minus h squared plus y minus k squared equals r squared, where h and k are the center of your circle. We've already had a unit on circles. Okay, so we're going to graph this one because it's supposed to be x minus h, so h must be 4, and y minus k, so y must be negative 3, and r squared, r is 9. So I have to go to 4, negative 3, and 9 would mean I need to go out 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and put my dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, and put my dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, put my dot, pretend I did. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I can draw my circle. So I graphed it. Now, if you needed to solve for y on this one, what you would have to do is we'd have to pick up this and move it over and get y plus 3 squared is equal to 81 minus 8 minus 4 squared, which would be x squared minus 8x plus 16. If I FOILed this, this would be x minus 4 times x minus 4. So when I put that together, I get x squared minus 8x plus 97 equals y plus 3 squared. I'd have to square root both sides. Actually, I think I'm going to go back to the other one. Y plus 3 squared equals 81 minus x minus 4 squared, because I got the difference of squares there. So when I square root it, this is 9 minus x minus 4. That's not going to work anyway. So look it back. Square root both sides. Y plus 3 is equal to x squared minus 8x plus 97 square rooted. Subtract your 3. So y is equal to the square root of x squared minus 8x plus 97 minus 3. So there's always a way to be able to solve for y and then put it into graph. And of course, I need plus or minus, so it does the top and the bottom half of the circle. If I don't put plus or minus, it'll only do the top half. If I put plus or minus, it does the top and the bottom half. Transformation. Transformation that shifts or reflects the original graph is a rigid transformation. A non-rigid transformation is a transformation that stretches and compresses it, and we've already talked about transformation. Now remember, a parent graph of a quadratic, A will tell you if it's stretched or compresses, or if it flips. If A is negative, it flips. If A is greater than 1, it stretches. If A is between 0 and 1, it compresses. Okay, and H moves it left or right because it's the x-coordinate of the vertex, and K moves it up or down because it's a y. So just looking at this one, because it's plus 3, it's going to move it left 3 and down 2. This one's going to move it left 3 down 2. This portion here compresses it by 1/2. Left 3 up 2. This part stretches it by 2. Left 3 down 2, and this flips it. So I go left 3 and down 2, and I have a regular parabola that's 1, 1, 1, 1, 2, 4, 2, 4. On this one I have a regular parabola, left 3, down 2, and I go over 1 and down 1, over 1 and down 1, over 2 and down 4, over 2 and down 4, and it just flips. But on the other two, a normal parabola is 0, 0, 1, 1, 2, 4, 3, 9, because it's in the form of y equals x squared. And if I take a half to it, I have to multiply it by a half, each of these y forms. So 0, a half, 2, 9 halves. So I go left 3 and down 2, and from there, 0, 0, then I do 1 to the right and up a half, 1 to the left up a half, 2 to the right from the vertex and up 2, and as you can see, it's getting fatter. The next one, 0, 0, 1, 1, 2, 4, 3, 9, we're going to multiply each of these by 2. So 0, 2, 8, 18. So I'm going to move left 3, and this one's up 2, a little different than the rest of them. And then I move right 1 and up 2, and left 1 and up 2. Remember, there's a line of symmetry coming down the middle. Left 2 and up 1, 2, 3, 4, up 8, 8. Not 4, because we're stretching it, and see how much thinner and skinnier it got? So you need to know what each of these portions are so that you can move your quadratic. And a reminder of symmetry. Remember, if for every x value in the domain, then the function is even if this is symmetric to the y-axis, and if you put negative x in and it becomes the opposite, it is symmetric to origin. So let's try. 5 times negative x squared minus negative x. So we get 5x squared plus x. Okay, that is not the same as we started with, and it's not the opposite. So this is not symmetric to origin or the y-axis. Negative x plus 3 becomes x plus 3. So this is the same, so it's symmetric to the y-axis. And I'll show you, I'll graph it in a minute for you. Negative x squared minus 3 times negative x plus 6 gives me x squared plus 3x plus 6. And this has neither either. So let's look. So we put in 5x squared minus x, graph it. Is this symmetric to the x-axis? As you can see, it's not, because here's the middle, 0, 0, and this is 3/4, and this is 1 3/4. So even though it kind of looks symmetric to the y-axis, it's not. And if we put in math, num, abs for absolute value of x and the absolute value plus 3, and we graph that, we look at symmetry at the y-axis, you can see that both sides are running the same. 3, here's the center, 3.5, 3.5, 4, 4. So we're good on that one. That's symmetric to the y-axis. And then the next one, x squared minus 3x plus 6. Graph it. You can see it's definitely not symmetrical to the y-axis or to origin. So that's a neither. So just because it has an x squared term does not mean that it's automatically even just because it's squared. Okay, you have to put in that negative. So this is neither. Neither. One-to-one functions and inverses. A one-to-one function is no two elements in the domain corresponds with the same element in the range. And to test this, we do the vertical line test for a function. For a, we can do a horizontal line test to see if it's a one-to-one function. So if it passes the vertical and the horizontal line test, it is it's a one-to-one function. So we're going to add that one-to-one portion, meaning that the x and the y, neither of them repeat either way. Okay? And it's also, horizontal line test is also used to tell if the inverse is a function. And we're going to get to inverse in a minute. Okay, so determine if it's a one-to-one function. The domain repeats. This is not even a function. No function. It's not a function, it can't be a one-to-one function. Okay, -1, 0, 1 doesn't repeat. 1, 0, 1. Okay, so it is a function, but it's not a one-to-one function because the range repeats. Domain repeats. Range repeats. -1, 0, 1, -1, 0, 1. Neither the domain or the range repeats, so it's called a one-to-one function. Domain and range do not repeat. Okay, so I could graph this. Start at +2, go up 1 and over 1, graph it. It passes the vertical line test, it passes the horizontal line test, it's one-to-one. Go up 1, make my parabola. It passes the vertical line test, fails the horizontal line test, so it is a function, but not a one-to-one function. Do my S-graph, passes the horizontal line test, passes the vertical line test, passes the horizontal line test, it's a one-to-one function. That moves it left 1, graph it, passes the vertical line test, fails the horizontal line test, so it's a function, but not a one-to-one function. So we're going to add this one-to-one function in, and all that means is that the domain and range does not repeat. It means it passes the vertical and the horizontal line test. Okay, talking about inverses. Inverse is the opposite as when you switch the x and the y. It's read f of -1. The domain, the range of the first one is the domain of the inverse, and the domain of the inverse, the range of the inverse is the domain of, okay, let's start again. The domain of the original becomes the range of the inverse. The range of the original becomes the domain of the inverse, because all you're doing is switching the x and the y to solve for y. And you can tell if it has a inverse by if it's a one-to-one function. It has to be a one-to-one function to have it be an inverse. Okay, so this does not pass the horizontal line test. So this is a function. Okay, it is a function, but it's not a one-to-one function. This is a function, but it's not a one-to-one function because it fails the horizontal line test. This isn't even a function. This is a function, and it's one-to-one. Function fails the horizontal line test, so it's just a function, no one-to-one. Passes the vertical line test, but fails the horizontal, so it's a function, but not a one-to-one function. So hopefully you get the idea of what makes a one-to-one function. Okay, we're going to now do inverses. To do an inverse, take f of x and replace it with y, because f of x is y. Then switch the x and the y in the equation and solve for y. The inverse functions are symmetrical with y equals x, which means you should be able to take the y equals x, and if you have a graph here, it should look like this here. It should be symmetrical to the y equals x line. That's how you tell if they're inverses when you're looking at them as a graph. Okay, so I want to know if the inverse of if this is the inverse of this, and I can do it two ways. The first way is I can take one of the two equations, I'll take this one, and plug this in. So I get half of 2 is x minus 4 plus 4 equals x. If you end up with x at the end, yes, they're inverses. I could do it the opposite way, and I could put the 1/2 and put the 2x plus 4 in it, and half of 2x is x, and half of 4 is 2, and I still get x, so they're still inverses. Or if I don't want to do it that way, I can always take one of the two, change this to y, switch the x and the y, because that's all what an inverse does. Take x minus 4 equals 2y, because I moved the 4 over, divide by 2, so 1/2 x minus 2 equals y. And I can see if I get the other side. Is this the inverse of this? So I'm going to plug it in. So I take the square root of x and square it. I take this one and plug it in here. This goes away and I get x. As long as I end up with x at the end, I have an inverse. So yes, they are, I didn't even spell this right. They're inverses. Yes, they're inverses. I need to take that grammar test again. Or I could take this, switch it, x is equal to square root of y, square both sides, y is equal to x squared. So yes, they're inverses. There are two ways of doing it. So we're going to find the inverse of each of these functions. Okay, good. This y, I'm going to switch the x and the y. I'm going to solve for y. Subtract my 2. X squared minus 2 equals y. Or x squared minus 2 is f to the negative 1x, which is the inverse. All I did was switch the x and the y. Make y. Switch it. Now remember, when you do an absolute value and solve it, you've got to split it into two. So x is equal to y and x is equal to negative y. So x is equal to y, divide by negative 1. Y is equal to negative x. And you need both sides of those to make your v as your inverse. but that will not pass the vertical line test, the horizontal line test, so the inverse is not going to, this won't work anyway. Because remember, an absolute value won't pass a horizontal line test. Y equals 2 over x plus 3. So x is equal to 2 over y plus 3. I'm going to cross multiply xy plus 3x equals 2. I'm going to pull the x out. Divide by x. Y plus 3 is equal to 2 over x, and subtract the 3. Y is equal to 2 over x minus 3. Or f to the negative 1 of x is equal to 2 over x minus 3. Y is equal to 5x. Switch. Divide by 5. X over 5 equals y. So f of negative 1x is equal to x over 5. Verify. 5 times x over 5 is x. Verified. Y is equal to 3x minus 2. Switch. X is equal to 3y minus 2. X plus 2 equals 3y. X divided by 3 plus 2 divided by 3 equals y. So f to the negative 1 of x, which is the inverse, is equal to x over 3 plus 2 over 3. Or you could have put x plus 2 over 3. Verify. 3 times x plus 2 over 3 minus 2. Drops. X plus 2 minus 2. X. Verified. Y is equal to 7x minus 5. X is equal to 7y minus 5. X plus 5 equals 7y. Divide by 7. X over 7 plus 5 over 7 equals f to the negative 1x. Or x plus 5 over 7 equals f to the negative 1x. Verify. 7 times x plus 5 over 7 minus 5. Cancels. Cancels. X. Verified. Y is equal to x cubed plus 1. X is equal to y cubed plus 1. Subtract 1. Cube root both sides. Third root of x minus 1, because they're both over there, so they're both getting cube root, equals y, which is the same thing as f to the negative 1x. Verify. Third root of x minus 1 cubed plus 1. See you later. X minus 1 plus 1. See you later. X. Verified. So an inverse is when you're switching the x's and the y's around. So you're literally picking up the x and putting it where the y is, picking up the y, putting it where the x is. To verify it, plug what you get back in. If you end up with x at the end, it's verified that they are inverses. Okay, variations. The types of variations that we're going to be using are direct variations, which are in the form of y equals kx, where y varies directly with x, so y is directly proportional to x, and k is the constant variation or the constant proportion. A direct variation can have powers, where y directly varies with the power of x. It's the same thing except x is raised to a power. Anytime you see varies directly, you put the k right next to the y and then whatever comes next to it. So whatever they're talking about. Inverse is when k is on the top and what's happening is on the bottom. Okay, so that's inversely proportional, and you can do inversely proportional with powers. And a joint variation is when you have your k and you have more than one thing happening. They might both be direct, they might be direct and inverse. Okay, so this is how I do it. I do them all the same as a formula. Therefore, you can do a direct as a proportion, but you can't do an inverse as easily as a proportion, so it's easier to put it all together. Find the mathematical model for the cost of electricity that has the monthly cost of $179.99 for an average of 3,098 kilowatts per hour if there is a direct variation between the cost and the kilowatts. So there's a direct variation because the cost and the kilowatts. So K, and I'm going to do W for the watts. K is my constant that I have to put in because it's direct. Okay, so my cost was 179.99 equals K times 3098 divided by 3098. So 179.99 divided by 3098 equals, see if we can change that to a fraction. We can't, so we'll round it. So K is approximately 0.058. So my formula would be C is equal to 0.058 W. So now if they gave me another one and I needed to know the cost, I could put the W in this. Or if I needed to know the kilowatts, I could put the cost in. So I always set it up as an equation first. Find the direct variation with powers. A single man, 194 pounds. You made that. 6 feet and 194 pounds. Seeks a single female for a long-term relationship. She must be athletic, smart, like movies and dogs, and have a height and weight similarly proportional to mine. How much would a 5'6" person who is proportional to him have to weigh? Okay, so we got two things. We got to find K first. So first thing we do is a single man has a direct variation. A single man is 6 feet, 154 pounds. So here is the equation. W is equal to KH cubed. His weight was 194 and his height was 6 cubed. So I need to divide by 6 cubed to find out what my variation is. So I have 194 divided by 6 cubed. 0.9, and I change that to a fraction. I can 97 over 108. So now I'm going to come up here and I'm going to go W is equal to 97 over 108 H cubed. Now I need to take 5 feet 6 inches, 66 inches. 5 feet 6 inches is 5.5 feet. So I might be plugging in 5.5 feet. So W is equal to 97 over 108 times 5.5 cubed. Times 5.5 cubed. Her weight should be approximately 149.4 pounds. So I took my equation, I figured out what K was, put K back in, and then put my new information in to find out what was missing. In New York City, the number of potential buyers in the housing market is inversely proportional to the price of the house. So, potential buyers is inversely proportional to the price of the house. I'm going to put B for buyers instead of P. I like to use letters so I know where things go. If 12,500 potential buyers buy $2 million for a $2 million condo, how many potential buyers are there for the $5 million? In this case, I'm going to set up a proportion. I'm going to cross multiply. So I got 12,500 times $2 million. So K is equal to 2.5 times 10 to the 5th. Oh, 10 to the 10th. Didn't even read that right. 10 to the 10th. That's what E means, times 10 to the. So I come up here, B is equal to 2.5 times 10 to the 10th over H. So B is equal to 2.5 times 10 to the 10th over 5 million. Now please make sure when you put it in the calculator that you put parentheses around anytime you have more than one thing in the numerator, just to make sure that the calculator handles it correctly. So I already have that. I'm going to divide that by 5 million equals, and my potential buyers should be 5,000. So I always set it up as an equation. I always find K, plug the K back in, and put the information back in. I find that's the easiest way to do it no matter what. The gas in the headspace of a soda bottle has a volume of 9 milliliters. The pressure is 2 atmospheres and a temperature of 298 K. Standard room temperature is 77 K. If the soda bottle is stored in a refrigerator, the temperature drops approximately 2.79 K, 42 degrees Fahrenheit. What is the pressure of the gas in the headspace once the bottle is chilled? And they gave us an equation as pressure is equal to K times temperature over volume. So let's start with what we start with. Okay, the volume was 9. The pressure was 2. We didn't know K. And the temperature, we either have to go 77 or 42. You can't make up your mind. Okay, so I'm going to use 77 because that makes more sense to me. So I have to divide by 77 over 9 to find my K. So 2 divided by 77 divided by 9. See if I can change it to a fraction. 1877. So K is 18 over 77. Go back up. P is equal to 18 over 77 times T over V. What is the pressure of the gas in the headspace once the bottle is chilled? So I'm going to be using 42. And the volume does not change. So P is equal to 18 over 77, 42 over 9. $18 divided by 77 times 42 divided by 9. The pressure is, wish that thing would stay up, approximately 1.09 atmospheres. And that I'm pretty sure does change to a fraction. Or you can put the pressure is exactly 12 over 11 atmospheres. So I make the formula, I find out what K is, I take K and plug it back into the formula, and then I put in the new information. It doesn't matter if it's an inverse or jointly or what there is. Okay, I hope you enjoyed this lesson on the second part of functions. I'll see you soon.